In a previous video, we put together a table of how many partitions there were of each individual number, up to 7 or so. But it's also interesting to see what pattern arises when you look at the lengths of certain partitions. So if we start with n equals 1, there's only one way to partition that, and it's 1 long. For the number 2, we recall there were 2 possible partitions. This one has length 1, this one has length 2. So there's one of length 1 and one of length 2. For n equals 3, we saw that there were 3 separate partitions, length 1, length 2, and length 3, where there are 3 numbers added together, or 2, or just 1. So we have 1 of length 1, 1 of length 2, and 1 of length 3. For the number 4, it starts to get a little more interesting, because we have 1 of length 1, 2 of length 2, 1 of length 3, and 1 of length 4. For 5, we need to do a little preemptive work here. 2, 2, 3, 3, 4, 5. So we have 1 of length 1 again. We have 2 of length 2. We have 2 of length 3, 1 of 4, and 1 of 5. And do the same thing for n equals 6. There's a 1, there's a 2, a 2, a 2, a 3, a 3, a 4, a 3, a 4, a 5, and a 6. So we have 1 of length 1, 3 of length 2, 3 of length 3, 3 of length 3, 2 of length 4, 1 of 5, and 1 of 6. Do the same thing for number 7, partitions of length 1 through 7, and we get the pattern 1, 3, 4, 3, 2, 1, 1. So at this point, you might start thinking ahead and trying to figure out what the pattern is. There's always going to be one partition of length 1, because that's just the number itself. There's always going to be 1 equal to the number itself, because, for instance, number 7 has length 7 if you write it as 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. But these other ones in between get interesting. For length 2, you have 1, 1, 2, 2, 3, 3. So you might predict that for number 8, you might get a 4 here. And I'll write a question mark because we're not really sure yet. What about here? 1, 1, 2, 3, 4. So you might think that's a 5. 1, 2, 3, is that going to be a 4? What is the pattern here? Is it really like something simple? But unfortunately, it turns out that it is not. For number 8, we have 1. The 4 is actually correct, but then it's a 5, 5, 3, 2, 1, 1. And you can work out exactly, if you want to, why there are 5 partitions of 8 that are length 3. But let's go ahead and do number 9 as well. For number 9, it took me a while to work this out, but we get 1, 4, 7, 6, 5, 3, 2, 1. Oops, off the page, 1. So now look for familiar patterns. Here, this was interesting, 1, 1, 2, 3, 5. We think, oh, it's going to be the Fibonacci sequence, but no, the next number is a 6. Here, it's not really clear what's going on. 1, 1, 2, 3, 4, 5, 7. That doesn't look like any pattern we've seen before. These are clearly all 1s. 1, 1, 2, 2, 3, 3, 4, 4. For 10, you can pretty much confidently think that there's going to be 5 ways of arranging unique partitions of length 2. Similarly to the others, you're going to have a 1, 1. You're going to have 1s and 1s for the length of n and n minus 1. It'd be nice at this point I told you what the secret was and how to fill out the rest of the table, but unfortunately in math, some things are just not that simple. In fact, we talked about in a previous video, P of n is the number of partitions of the number n, but no closed form formula for P of n is known. In other words, we can get to it. We can fill out any row of this table, plus the sum of each row is the number of partitions that we have. Number of partitions for 2 is 2. 5, there are 1, 2, 3, 4, 5, 6, 7. So we know for the number 5 there are 7 total partitions, but we don't have a formula for that in terms of like an x squared or a sine of x or anything like that. We can get to it. We can always figure it out using computer programs or something called recursion, but we don't actually have a formula for this. One way you could think to get to a formula for this, the total number, if you add up this entire row, would be to try to figure out the pattern for each column and then add all those up separately. So have at it if you think that would be a fun little exercise.